Welcome. Today we're going to be working with function notation, how to solve and how to write equations in function notation. Function notation can be represented by really any set of two letters. In this case, we can start with f of x, g of x, and then h of x. Again, how is it read? It means that we have f of x is g of x, h of x. And all this means is that we are given a name to these functions to distinguish them from each other, saying that the function of f, the function of g, and the function of h have different names because they have different appearances. They look different and they represent different scenarios. One can be speed, one can be the falling of an object, etc. So again, the letters in front just represent the name of any specific function. So the rule here, it says what's happening, and really we look at is what is happening to x to get the corresponding f of x value. So really what's happening, and again, what's my rule? And the rule is just saying f of x equals what? Well, let's look at the rule here. And it says here that we are, for every x value, what am I getting out? So what's going to be the rule? Well, it's going to be x plus 6. And you can prove this because every single time that I put, for example, if I put a 2 here, what do I get out? I get out 8. Again, this rule, let's go back to the before we go here. We can say that if we put in, let's say a 2 here, a 2 there, f of 2 equals 8. I'm over here, I put f of 5, I get out 11. And the reason why is because I am replacing my x value for this x value. I am replacing my x value for this over here. So to go ahead and solve this over here, I say 5 plus 6. Right, that equals 11. Let's do the last one, f of 10, right, f of 10. I plug in my 10 value for my x, and I get 10 plus 6, and that equals 16. So these are my outputs. This is the rule. The function rule is telling you what's happening as I have these certain outputs. What do I get? Or what are my outputs for certain inputs? That's what it's asking. So over here we have another trend here. We're going up by, in this case we're going here negative 3. So we're going to go negative 3 and then 0, then 5. So what's going to be the function rule here? What's going to be the function rule here? And so go ahead and do this. You can kind of say, okay, what's the trend? We're going from here to here, and we're going from here to here. And so here we're going up 6, and over here we're going up, let's say here we're going 10, right? So what would be that rule? What would be my f of x? Okay, we look at that. And it's going to be f of x equals 2x. So what's happening here is we are simply multiplying. We're multiplying by, in this case, a 2. So if I plug in my negative 3 here, this means I get 2 times negative 3, which equals negative 6. I put in my 0 over here, 2 times 0 is just 0. And I get finally 5 for my input, and I get 2 times 5, which is going to be 10. And so that's the rule. And again, all we're doing is we're looking at what's happening to my outputs as I have those inputs there, or what's happening to my outputs. So again, going back to function notation, what is function notation? I mean, all we're doing is we're replacing the y with the f of x. So f of x equals this, and then what's the rule? The rule is on the right-hand side of the equal sign, meaning what's happening to my x value. In this case over here, what's happening to my x value? I'm adding by 6. So my inputs are always going to be, again, your x values. The function rule here, it depends whatever you have, right? Whatever you have there. For example, it's going to be x plus 3, let's say. Whatever x value you have, you're going to be plugging into here, plus 3, and then you're going to get your output. So the idea behind this, and where we're going with this, is we are trying to graph. When you graph, you need an x coordinate and you need a y coordinate. And that's where we're going with this. We're trying to lead us in the direction of eventually graphing stuff with our graphing functions. So as you can see here, we are doing the input into my original function here. I get my outputs, and you get a set of x values and a set of y values. In this case, this is a function. There's only one output for every input. And you can see here that now we have located at least 3 points. And 3 points would be enough for us to go ahead and graph, although we probably need a few more points to go ahead and graph on a two-dimensional plane. But again, the idea is, can we see a trend in the data? Can we see a trend when we graph this? And that's where, again, that's where we're going with this. Just a reminder that domain's always my x values, range is always my y values. So in this case, this is another example here. When you have an equation that has more than one x variable inside, like this, again, this is just for the future here. We have an x value here and an x value here, or x variable. When you plug in your input for x, you are replacing every single x value with your 2 and 2 and 2, and then you evaluate. So in this case, we get 2 squared minus 6 plus 1, and again, just remember this in the future, that if you have one x value, we are replacing that one x value. If we have 2, we're replacing those 2 x values.
If you have three x values, then you are replacing those three x values. That is it, folks. Thanks for